Good morning, students. So today class we discuss about the unit 4 of electrical technology, that is three-phase induction motors. Three-phase induction motors. Generally, the three-phase induction motors is mostly used motor in industrial wise and also some workshops. So most of the motors used in industrial purpose is nothing but three-phase induction motors only. And workshop also we are utilizing three-phase induction motors. Why? Because so many advantages is there for three-phase induction motors. Because of that advantages, so widely used in industries and workshops. Generally, the three-phase induction motor widely used in AC motors. That means motor is nothing but it uses electrical power and produce mechanical power. Right? Almost 80% of the motors are three-phase induction motors among all the motors used in the industry and workshops also. Therefore, so it is the most important motor compared to all other type of motors. That means it may be utilized in industrial as well as commercial as well as residential settings also or residential purpose also. So generally, what is three-phase induction motor? A three-phase induction motor is a type of AC induction motor. AC motor. Generally, we discuss till now in our subject. We have to discuss about the DC generator, DC motor, transformers, right? So that means we have discussed about the DC motors only till now, but now we have to discuss about the AC motor. So three-phase induction motor is a type of AC motor which operates on the three-phase supply as compared to the single-phase supply, right? So we are giving the three-phase AC supply to the induction motor. So induction motor, three-phase induction motor works on the principle of mutual induction principle. Mutual induction principle. Mutual induction principle. That means the three-phase AC supply, whenever we are giving the three-phase AC supply to the induction motor, that may produce an electromagnetic field in the stator. That means whenever we are giving the three-phase AC supply, that may produce an electromagnetic torque or rotating magnetic field. That may produce an rotating magnetic field RMF in the stator winding. That may leads to generate the torque in the rotor winding. Right? That means we are giving a three-phase supply to the stator, at which an rotating magnetic field is produced that may lead to generate the rotating torque in the rotor winding. Whenever the torque will be developed in the rotor, that may lead to the running the induction motor with some speed. So look at the industrial three-phase induction motor. I mean, we have to purchase the three-phase induction motor in the market. So the picture of three-phase induction motor will be like this. Now, because of already we discussed it, the three-phase induction motor is the most widely used motor. Most widely used motors. Three-phase induction motor is mostly widely used motor compared to all other motors because so many advantages is there, right? So now we discuss about the advantage of three-phase induction motor. Generally, generally a motor is nothing but it will take the electrical energy and it will convert mechanical energy. Why we are called why we are utilizing more than 80% of motors in industries as three-phase induction motor is nothing but first its construction is very simple. Construction is very simple and robust. Construction is very simple and robust. That means it is mechanically very strong. Mechanically very strong. And the cost wise it is very less cost. And it is a self-starting property. Three-phase induction motor is a self-starting property, self-starting motor, whereas in single-phase induction motor is not a self-starting motor. So three-phase induction motor is a self-starting motor, and it gives more, it gives higher power factor, and hence good speed regulation, and also it has more efficiency and more reliable. So that means, and it requires less maintenance. So that may be utilized in any type of land on any type of situations. That means, so this motor is very robust, and also it will having a less maintenance because of that robust construction. It is having a less maintenance. And starting torque is very high for slip ring type of induction motor. The starting torque is very high, right? Because of those advantages, the induction motors may be utilized in so many industries. Although it is having more advantages, but it will having some disadvantages also there. The speed decreases with increasing load. Speed decreases as increasing the load. Second one, speed control methods for three-phase induction motor is quite cost. Speed control of DC motor is very easy and simple. That's why speed control of DC motor is more advantage compared to remaining all speed control of motors. Speed control is quite complex, and also the speed decreases when load is increases. Generally, day-to-day life, we can find the various applications of three-phase induction motors compared with a single-phase induction motor because it is having more advantages. Reliable, robust, power factor is good, regulation is good, efficiency is very good, maintenance is less, cost safer in cost. So because of all these advantages, so this three-phase induction motor may be utilized in so many industries. That means applications in not only in industries, we are utilizing in day-to-day life also. So what are the different applications of three-phase induction motor? Lifts. First of all, lift. Lift is nothing but it at the starting of the lift, it will having high starting torque. That means starting torque is where the starting torque is high. At that situation, we are utilizing a three-phase induction motor. That is also especially slip ring induction motor. Where starting torque is high. Lift, crane, hoist. These three requires high starting torque. That means, so high starting torque three-phase induction motor is nothing but slip ring type of induction motor. Coming to the next one, large capacity fans, lathe machines, crushers, textile machines, oil extracting mills, all these having moderate starting torque or medium starting torque. So at that time, the three-phase induction motor is utilized, especially squirrel gauge induction motor. So they don't ask, suppose they asking separately, you can write separately. Suppose they don't ask separately, you can combine all these applications, cranes, lift, elevators, hosts, large capacity exhaust fans, crushers, oil milling, oil extracting mills, the textile mills, so chocolate industries, whatever it may be. Oil refining machines, you can give so many applications for the three-phase induction motor. Generally, a three-phase induction motor, because of all these applications, we may utilize it in more than 80% of the industry, right? Generally, three-phase induction motor is also called as self-starting machines and also called as asynchronous machines. Asynchronous machines. That means it does not running with 1500 RPM. It does not running with synchronous speed. That's why three-phase induction motor is also called as asynchronous motor. So that is, the induction motor is always running with below rated speed. That means below 1500 RPM or above 1500 RPM. That's why. So it is always running with asynchronous speed. That's why you can also call as asynchronous motor. Now go for the construction. Construction of a three-phase induction motor, very important in exam point of view, JNTU exam point of view. Generally, a construction of three-phase induction motor mainly consists of two parts. One is stator, another one is rotor. As I said, first slide, as we are applying three-phase AC supply to the stator winding, at that stator winding, it may develop a rotating magnetic field, RMF, that may be rotating with synchronous speed, right? Because that may lead to generate the rotational torque in the rotor that may moving the motor, right? That means construction of three-phase induction motor consists of mainly stator and rotor. Stator is nothing but it is the stationary part of the three-phase induction motor. Rotor is nothing but it is a rotating part of the three-phase induction motor. So look at the figure, stator and rotor pictorially. For industrial purpose, for practical purpose, the three-phase induction motor may be separate as stator and rotor. That may be, look at the picture. So this is the stator and this is the rotor. This part is the rotating and this part is not rotating. This is the rotating tower and this is the stator winding. So it may consist of conductors also. Look at the overview of three-phase induction motor. That means, so this is the wiring cover. We are giving a three-phase supply from this box, and motor frame. This is the frame. That means stator frame. Below this stator is available, and this is the rotor. This rotor is the rotating part, and it having blades, fan blades, and this is the bearing, end bill or end rings. So this is the one end bill and this is the another end bill. So in this manner we have to combine all these parts that may resembles the three-phase induction motor. That three-phase induction motor may be utilized in industrial purpose. Look at the picture clearly. Now we go for the stator. Construction of a three-phase induction motor. As usual, it consists of stator and rotor. Stator, now we discuss about the stator. Stator is a stationary part and it is made up of high grade steel laminations to reduce eddy current losses. Stator is a stationary part. It is made up of high grade steel laminations to reduce eddy current losses. So laminations are insulated from each other. Slots are provided as shown in figure 1. Look at the figure. This is the stator core and this is the stator winding and this is the stator core. This is the frame, outer frame. So now to place three-phase stator winding in the stator slots. Stator has three main parts: outer frame, stator core, stator winding. As look at the figure clearly. This is the outer frame and this is the stator core and this is the stator winding and this is the stator slot. Outer frame is nothing but it is only outer body of the motor. That means it is a protecting cover and it protects the motor from the moisture effects. Is there any effect from the moisture? That may be protecting the motor from that atmosphere, moisture, atmosphere effects. That means it will completely protect the inner part of the machine. Next one, stator core. It is built up of high grade silicon steel material. That means it will carry the alternating magnetic field, that is rotating magnetic field. Whenever we are giving the AC supply to the stator core, so that it may develop the rotating magnetic field. And last is stator winding. It is a three-phase winding. It may carry the three-phase current. Look at the figures clearly. So these are the slots: core, stator core, stator slots, stator winding made up of high grade silicon steel. So in between these two, a rotating magnetic field is produced. So look at the outer frame of stator and this is the winding. And look at the picture clearly. These are the slots and conductors. The conductors may be housed in the slots, inner periphery of the slots. That means the stator winding is made up of copper wire. So that may be star or delta connection. Sometimes stator is all, in some textbooks stator is always connected in star, or in some textbooks the stator may be connected in delta connection, depending upon the that means rotor construction. When the three-phase AC supply is given to the stator, as you said in the first slide, a three-phase alternating flux is produced that may be rotating with a synchronous speed. That three-phase alternating flux is also called as rotating magnetic field, RMF, that may be rotating with synchronous speed along the stator core. So look at the picture clearly. So that alternate rotating magnetic field is rotating with synchronous speed, that may be having empirical formula NS is equal to 120 F by P RPM. So now look at the picture clearly. So this is the outer frame and this is the stator core and this is the stator winding and is the conductor slots. So now conductors are placed in inner periphery of the slots. Now whenever we are giving the three-phase AC supply, the conductors may be cut the magnetic flux, it may be develop the alternating flux, that is three-phase alternating flux. That alternating flux is called rotating magnetic field. Look at the lines, look at the arrow mark lines. These are the rotating magnetic field. So this rotating magnetic field may be rotating with a synchronous speed, that is 1500 RPM rated. Next part is rotor. The rotor is may having again two parts, classified into two parts. One is squirrel gauge rotor and slip ring type of rotor. Generally, as you said earlier, rotor is nothing but a rotating part of the induction motor is rotor. The rotor is in a cylindrical shape or it may be a wedge shaped section. Because of cylindrical shape, it may reduce the eddy current and hysteresis losses. So squirrel gauge rotor and slip ring rotor. First we go for the squirrel gauge rotor. Generally, look at the figure clearly. Here So the rotor may having the conductors that may be made up of aluminum or copper bars. So and these rotor conductors or aluminum conductors are fixed in between two end rings, and these aluminum bars or copper conductors does not placed horizontally. It may be inclined with some angle. Because of inclined that some angle, we are getting the unidirectional torque. So that means we can also call that inclination of slots is also called as skewing of slots. Because of that skewing of slots, we are getting the unidirectional torque that may gives the motor is always production of torque. That means that's why the in three-phase induction motor is also called as self-starting motor or asynchronous motor. Generally, as you said that copper and aluminum bar conductors are placed in these slots that may be short circuited by end rings. So the rotor winding is permanently short circuited. If suppose it is not possible to short circuit the rotor, there is no developing of torque. That means there is no rotation of induction motor. Whenever the rotor is a short circuited, now the three-phase AC current is flowing through the rotor conductors, and then it may develop the torque because of twisting moment of the force or turning moment of the force about an axis. So a torque will be developed. That torque may rotate the or moves the three-phase induction motor. So because of this inclination of conductors inclined with some angle, suppose maybe below 40 degrees. So in between the two end rings, so you are getting the unidirectional torque, right? So mainly it will reduce the magnetic locking of stator and rotor. Magnetic locking is nothing but the saturation of the magnets that may be reduces. Whenever the magnets are saturated, so you may increase the load also, it does not give the values. That means it does not give the slip and speed values according to that increase of load. So that means skewing of aluminum conductors or copper conductors may reduce the magnetic locking in between the stator and rotor. That means there is no saturation of the magnetic cores. And also it will reduce the humming. Humming is nothing but whenever magnetic locking is occurring in between the stator and rotor, it may be having some humming noise. That means, so to reduce that humming noise, because of this inclination of aluminum conductors, and also we are getting unidirectional torque. These three advantages are available whenever we are skewing the rotor aluminum conductors. Suppose we cannot skewing the aluminum conductors in between these two end rings, these are not possible. That means the torque is not uniformly throughout the machine. In marketplaces, so the original squirrel gauge three-phase squirrel gauge induction motor picture is looked at clearly. So these are the aluminum conductors inclined with some angle, and this is the conductors may be housed in the here. Another one, phase wound rotor or slip ring rotor. So before going to this one, the squirrel gauge induction motor may having the moderate starting torque and high maximum torque. Because of these situations, we may utilize this squirrel gauge induction motor in normal speed applications. That means normal residential purpose applications, day-to-day life applications. The squirrel gauge induction motor is highly utilized. That means fans and refrigerators, and may also cooking purpose, welding machines, and so many normal day-to-day applications. This type of motor is widely used. Now go for the another rotor, that is phase wound rotor. phase wound rotor or slip ring rotor having the slip rings. That's why this type of rotor is called slip ring induction motor. This type of rotor consists of 3 slip rings which are mounted on the shaft of the motor and with braces as shown in the figure clearly. The main use of braces is and slip rings are to collect the external resistance to the rotor circuit. Look at the figure clearly. The stator may be connected star or delta, that may be depending upon the rotor construction. Suppose rotor is a star, stator is star or delta, whatever it may be. Stator put in the star, that may be more useful. So star connected rotor conductor, R phase, Y phase, B phase. So the end of the 3 phases may be connected to the 3 slip rings. Look at the figure clearly. And this rotor winding may be put on the shaft, motor shaft. So end connections of the 3 phases R, Y, B are connected to the one end of the slip rings, and another end of the slip rings may be connected to the braces. So now that braces are connected to the 3 phases, that means external resistances, and this external resistance is also connected in star. Now what is the purpose of slip rings and braces? Nothing but you will collect the current from the rotor winding, rotor 3 phases. Because of this external resistance connected to the rotor, so that means, so this slip ring induction motor has high starting torque because of starting torque is always proportional to the resistance. Here the resistance is available externally, whereas in squirrel cage induction motor, the conductors are enclosed with a end bars, end rings. That's why there is no external resistance we have to put into the squirrel cage. That's why that is not utilized for high starting torque purpose. That may be utilized for medium or low starting purpose. But coming to the slip ring induction motor, because of this external resistance connected to the braces, so this may be utilized for high starting purpose, that is cranes, lift, elevators, hoist. All these applications may be under squirrel cage type of induction motor. So practical squirrel cage slip ring induction motor. Look at the figure. This is the rotor and this is the extra resistance, external resistance connect to the rotor from the external. I mean, so this is the rotor circuit, slip ring rotor circuit, winding, all these things. Now this is connected to the leg. So totally stator and rotor, stator of a 3-phase induction motor, rotor of a 3-phase induction motor. Now comparison between squirrel cage and slip ring induction motor more important for as per JN2 examination point of view. So squirrel cage induction motor having the simple and robust construction, whereas in slip ring induction motor is difficult in construction because it is having, you have to connect a external resistance to the slip ring induction motor, and squirrel cage induction motor requires less maintenance because there is no braces, there is no slip rings. Whenever braces and slip rings are there, is nothing but you have to replace the braces and slip rings regularly. That's why maintenance is more in slip ring induction motor. Whereas in squirrel cage induction motor, that type of arrangement is not available. The conductors are ended with 2 end rings. That's why there is squirrel cage induction motor requires less maintenance compared to the slip ring. And possibility of connection of external resistance is nil. That means there is no extra resistance connected to the rotor circuit in squirrel cage induction motor. But here an extra resistance is connected to the rotor circuit that may increase the starting torque, right? Next, and it is having high efficiency and high power factor in squirrel cage induction motor. Why? Because as braces and slip rings are included, so that may be reduce the efficiency. But coming to this one, it is having high efficiency and higher power factor, whereas in slip ring induction motor, efficiency decreases due to power losses because of in additional resistance circuit. And cost is also less because of absence of brushes and slip rings, cost is more. Totally the difference between squirrel cage and slip ring is nothing but brushes, slip rings and external resistance. These three things will be extra added to the slip ring induction motor that may be having so many losses and cost wise also high, right? So very, very important. So difference between this squirrel cage and slip ring induction motor. Thank you. If you see this video, please subscribe the DBS talks. Next class we discuss about the principle of three-phase induction motor.